Okay, terrific. All right. Well, thanks, everyone. Sorry for the technical difficulties. Zooming is always fun for a little bit. But thanks again for joining us. So today we're going to be discussing our men's health portfolio, particularly the DynaCAD for prostate MR, and how it ties into the URINAV fusion biopsy programs that many of you are involved in. Just a couple of quick slides, just an introductory information, if you will, here regarding the disease management solutions that Philips offers. And we were sort of formerly in vivo, now rebranded under the Philips umbrella as disease management solutions. And as many of you know, we do a lot of different things in the radiology space. I think there's a lot of radiology folks online. Today's focus obviously will be on our men's health portfolio with prostate cancer. But just so you know, some of your colleagues are likely using other solutions from us, like the DynaCAD for breast, for example. And we're actually going to have a breast MRI session next week. We're also heavily involved in the lung cancer screening space. And so we have a solution there, which will be a webinar in 2 weeks from this week. So lots of activity here, sort of in the web series that we've launched here. Obviously, we're very heavy in MR patient safety. I think a lot of your facilities are using our MR patient monitors, ferromagnet detection, orthopedic coils, and so forth. So a very broad portfolio of solutions. In the men's health space, you can see that we offer a lot of different products, basically an end-to-end approach for prostate cancer, from imaging to biopsy to ultimately treatment options. And in particular, you know, the growth of prostate MR as fueled by urology to be able to add that as their compendium in sort of adding imaging to the biopsy process. The DynaCAD for prostate and how it ties in with URINAV, with the fusion biopsy system, is something that I think you all are familiar with. So we'll expand on that, and Ed will jump into that in just a moment. We do see a lot of movement into the transperineal space. We had actually a URINAV transperineal webinar last week, and it was really well received by urology. So just so you know that there are a lot of things that are sort of growing in this men's health space for us. Obviously, creating that sort of ecosystem between the DynaCAD that you all use or are interested in perhaps, and how that ties in with URINAV to be able to send over those segmentations and targets. And then once the biopsies are done, we do have the capability now of taking those cores and actually putting them back into DynaCAD in what we like to call a reverse fusion, and look at some correlation. So this is one fairly busy slide, I'll say, but it is an important slide that Philips has really invested heavily in this men's health space and prostate oncology solutions. And typically the top line is sort of the current workflow was up until MR guidance came into play, where you do a PSA test, have a consultation, do a trust biopsy, and then subsequently sort of repeat this. Potentially a patient has rising PSA with negative trust biopsy. What do you do? So with the advent now of MR prostate and URINAV, we're able to do that. But you can see all the other pieces of the puzzle. We see a huge opportunity in digital pathology, for example. So this is where we're able to digitize the path samples and actually have them, encoded and digitized and shared with a lot of pathologists. And so, much where PACS was, 20 years ago, I think digital pathology has a huge opportunity for growth, add in genomic testing, and also being able to do multidisciplinary tumor board preparations now with a platform we offer. And then ultimately into the therapy space, where I think a lot of this is going, whether it's focal therapy sorry, I'm going to just unmute for a moment. Ed, can you hear me okay?
Yes, I can hear you just fine.
Okay. And then in the therapy space, and then ultimately going into follow-up. So the last slide I wanted to just highlight is the multidisciplinary tumor board dashboard. As you can see here, this is something that Philips has essentially organized a platform that takes all this disparate data. So much of the work that you all are doing in the radiology space with DynaCAD, the URINAV biopsy information, the pathology data that's coming from the laboratory information systems, and looking at rad path correlation, layering in the genomics piece of this, looking at medical history, and ultimately creating the appropriate pathway for the patient, radiation treatment planning. whether it's focal therapy, IMRT, or prostatectomy, or so forth. This is something we're really excited about. It really provides seamless access to all this disparate data, and it's something we'd like to maybe share with some of you for the evolution of your men's health programs. So with that, I'm going to actually stop my sharing and pass control to Ed. Ed, if you want to grab the screen now.
I can. Can everyone hear me okay?
Yep, we can hear you.
All right.
And all right, starting to share screen. There you go. Perfect. Thank you.
Appreciate it. All right.
Well, and by the way, I'm sorry, Ed, just one mention here. As Ed presents the DynaCAD piece of this and into the EuroNav, if there are questions, if you wouldn't mind, you could just shoot them in a chat to me in the buttons on your Zoom screen. You should be able to do a private chat to Pete Kwiatek, to me, the host, and we'll go through some Q&A at the end of this. Sorry about that, Ed. Go ahead.
Awesome. Well, again, my name is Edward Ramirez. I'm one of the clinical application specialists. The goal of the meeting now would actually be broken up into two main sections. One section is going to be more of a 99% of your workflow, exactly what you're going to cover, kind of the day in, day out operations. And then the second set, we're going to break off a little more into a deeper dive that's going to help some of the more advanced users. So at least everyone's going to get quite a bit out of the meeting today. So one of the first things that we would cover, as we can see here, is our patient browser. We know that this is showing everything that is introduced into the DynaCAD system. So from here, what we're looking at is any study that's actually acquired at the magnet level, we're going to send the packs, and we're also going to send to DynaCAD. We do have our quick query functions, know that we're able to then condense our list down to last day, last week, just to make it a little easier. But let's go into an actual study. All right, can everyone see my screen?
Yeah.
Okay.
Yeah, Ed, I can see it.
All right, so first things first is that we're looking at here is going to be, the first thing that we're looking at here is actually going to be your hanging.
Rosy. Ella está usándolo. ¿Tú quieres usar el mío, bebé? No, es que...
Okay, sorry about that. All right, so first things first that we're looking at here is actually your hanging protocol. So the view that we have typically is going to be our dynamic series with the color overlay. Bottom left-hand side, typically we'll place like an axial T2. In the middle, we like to place an ADC, a DWY here on the bottom right-hand corner. And then from there, we'll have the sagittal T2 sequence. So first things first, especially when we're looking at how our workflow is going to start, is one of two things. Whether we're working in the interventional piece or working towards a strict diagnostic piece, we want to look into starting with our gland segmentation. So in regards to gland segmentation, that's going to be our tool here. Once we open the study, what's going to happen is that DynaCAD is actually going to post-process the axial T2 sequence, and then it's going to be able to actually show the contour around the anatomy. Now, there's two pieces that we kind of want to go through this process. One, diagnostically, the way it's going to help us is going to give us the TC volume as well as the dimensions. Double down with that, if you are having a referring urology clinic that's actually doing the EuroNav, this is going to be a key piece that's going to be used in order to do the segmentation and be able to then target and biopsy later on. And actually, if you stick around a little bit, I'm going to show you exactly what that's going to look like on the urology side for those that haven't seen it before. So first things first, what we want to look at is the contour around the anatomy is really more of a verification. So the system's going to do its first pass. As you see, it undershot in a couple of areas, overshot it in a few, but more than anything, the system's going to look for the capsule space in the T2 image itself and be able to do the automatic contouring for you. So what we would do is come to any one of the areas, we would left click and hold and be able to make that adjustment. Now I'm going to window this a little harder just to make it easier to see. So again, left click and hold, we would either increase or decrease depending on the area that we see. The part that actually turns yellow, this is actually our region of influence. So we see as the region of influence is a little bit larger, we're going to be adjusting a larger point of area. So under here, we would actually have our region of influence. So if we left click and hold, we can increase and decrease exactly the area that we want to adjust. So where that would come into play is here, especially on the apex. Let's say we want to make a little bit more of a fine-tuned adjustment. So I'm going to make that a little bit smaller, get back to my grab tool. I would left click and hold, and now you can see the area that I'm adjusting is a little bit more as a contour to the area that I want to adjust. So the main thing that you want to look at is some of the hotkeys. So if I hold down the control key on my keyboard, as you see, the tool actually changes. So here it's automatically changing to the region of influence tool. If I let go of the control key, now I can left click and hold and not have to worry about switching back and forth in between the tools. So as a review again, you're going to hold down the control key. So hold down control, left click and drag. You can increase and decrease your region of influence as necessary. Let go of both, left click and hold, and you're right back in business. Now, a couple of things in regards to what's happening with the gland segmentation, especially where it comes into the reformat. So the reason for the reformats themselves, we're wanting to make sure that the anatomy is contiguous between all planes, since we are taking an adjustment of a three-dimensional sphere. So a quick little tool that's going to help you out, especially if the image itself is a little too degraded. If you right-click in the series, and from here you go to non-reference series. Don't go to reference series because you're actually going to change the sequence that the URNav is going to use, so you don't want to do that. So come here to the non-reference series, and you can actually place in the physical sagittal T2. We can do the same here with the coronal, and now you'll be able to actually view the anatomy a little better and still be able to get the same options as we spoke of before. Use our control key and be able to make the adjustments and still be able to do our contour pretty quickly. Now, when it comes to the gland segmentation, a couple of things to look at. You want to use the sagittal more for your base and your apex, just to kind of get you in the ballpark. The same thing with your coronal image, just to get you in the ballpark, and then spend more of your time on the axial, simply because that's the image that's actually acquired. So the resolution is going to be a lot better. So the last little hotkey that we would have would be the shift key. So if you hold down the shift key, it actually turns into the smooth tool, which is a tool that we have here at the bottom. So the smooth tool is literally just an adjustment. It's one thing that you don't want to use quite a bit of because it will actually shrink down your entire image. So if I go crazy on the smooth, as you see, it's going to shrink down quite a bit. So again, try to use those hotkeys, especially when it comes to your workflow. It's really going to help keep the sequence moves a lot faster, and at least that way you're not having to worry about spending 5-10 minutes just segmenting out the anatomy. So kind of like I said before, diagnostically, where it's going to help us, it gives us a CC volume as well as our dimensions, and which is something that you can actually replicate for that patient, especially if they come back for treatment at some other point. You can see whether or not the prostate is shrinking or it is enlarging, depending on what the treatment options are available. So the important part, especially where it comes into a gland segmentation for URONav, you want to make sure that you approve the boundary. If you save, is as if I'm going to come back to it later on, just because we're reading a case, we have to go do a procedure, whatever the case would be. Once you hit save, it's actually not going to give the stamp of completion that's going to send it over to the URONav. So it's important to hit approve. Once you hit approve, you press OK. As you see, all of my tools disappear across the top. I can hit either the cancel or I can hit the exit. Now, if I look at all my images, I have that information stamped on all my sequences. So that's one step. So now let's go into the actual reading process. So there's a couple things that we can look at. One thing, of course, if we double click, we can go full screen, double click to get out of full screen. We know now how on the PyRads Lexicon 2, it's pretty much broken up in between the type of sequence that we're looking for, different parts of the anatomy. So for the transitional zone, we want to spend more time on the axial T2. For the peripheral zone, we want to spend more time on the ADC and the DWI. So speaking with that, let's look at the actual ADC itself. So by doing a quick scroll, we can see that we have quite a large infiltration here within the transitional zone. We have an area here within the peripheral zone itself. If we then look at our DWI, we can see varying amounts of signal within these same areas. So when it comes to your workflow, it's really just depending on how you were trained. So when I originally trained, I trained from axial T2 to ADC to DWI for confirmation. But going with the lexicon, no, we can go back and forth in between these options. So one thing that I like to show is in regards to the fusion map. So instead of having to do this back and forth and see whether or not these values are really helping us, you do have an option called the fusion overlay. So what I did was I right-clicked over my axial T2, I go over to fusion overlay, and I'm going to place my ADC. And this is actually a hang-in protocol that can be placed onto your sequences, so you don't have to worry about manually doing that. And we'll cover hang-in protocols as well. But one thing that you can see, here's the area that we spoke about in the transitional zone, and the same area that we're looking at here in the peripheral zone. So what we're looking at are the physical ADC values that fall within the axial T2 image and how they correlate to the image underneath. So especially when it comes into the read, instead of having to draw our attention between two different sequences and not being able to quantify what is actually a ADC restricted event, we now have this overlay that gives us that option. So let's look at this a little bit further. So we can see here that we have some kind of an area that will be demarcated on our T2. And if we look underneath the sequence, we see that same option. So now let's talk about how we would create an ROI. So our ROI tools are actually here at the front, or we can do it under the right click, whichever one works out easier. I'm a right click person, so I'm going to go with the right click. So first thing that we would do is we would left click and hold and contour the area that you want. Now the part to remember here that this is only a two-dimensional area. So we're only doing surface area or length and width. So if we were to actually close this case and let it go on to biopsy, this will look like a pancake on the urology side. So that's something that we don't want. So just remember, you would have to right click inside the ROI, go to our first option, which is edit make 3D. And now if you look at my cursor, I have a 3D cursor. So from here, I'm going to chase my area around, or roughly within here. And it gets a little muddy, but we'll include it there. And it pretty much disappears. We'll go the other direction. Let's just say we have a little bit there. So once you're happy with the area you contoured, right click outside the ROI, then end edit. So now we're looking at our 3-plane dimensions. Let me put this a little bit in a better area to see. So as you see, we're looking at our longest distance, our shortest distance, and then our orthogonal distances. Now, the main thing here is that we do have to use the grayscale image in order to create an ROI. The reason why we have the 2D and the 3D, because these are breast tools. So we do have to have the freehand option because we have to contour the area that we see of interest. Once we're happy with our area, the reason why this axial T2 is blue is because that's the sequence that the urinav is going to use in order to import and be able to do the targeted biopsy. So what that would look like, and this is something that you physically don't have to do, but we can show the prostate boundary, and now we can see the boundary and then the ROI, how it sits within it. We do have, of course, reporting functions that we'll talk about in a moment, but at least this way we can see whether or not we have extracapsular spread or not. And I just didn't include a little bit more area of the peripheral zone, but this is a good way to see, does it fall within the actual prostate? So within that, once we've created an ROI, we can right click inside the ROI. And now we have our next option. And this is really more of an option. It's not something that you definitely have to do, but it really helps, especially when it comes to the reporting feature, by being able to edit then the PIRADS information. Especially when it comes into what we can create as a report and then archive back to PACS. This is a really good way of showing the workup, and it's a quick snapshot instead of having to reread the report and go through that process to figure out the impressions. We can actually physically see where everything lies. So we would start here, place, let's say we're in our peripheral zone, a little bit towards our apex. We can place in a PSA value, and let's say I have a PSA value of 10. If I hit the question mark, I have my scoring values. So instead of having to switch back and forth and reading your one sheets when it comes to your PyRads lexicon, we actually have the PyRads 2 already built into the system. So we can mark whether or not if it's an index lesion, primary or not, extracapsular spread, and then the same classifications. So if you see here, we actually have two different classifications for whether it's in the transitional zone or if it's in the peripheral zone. And the reasoning behind it is because the scorings are essentially the same, but it does give a little bit more identification as to the areas that we find of interest, as well as what parts are actually infiltrated. So in the event that you have a referring urologist that doesn't have a URNAV, they're able to use this information and create a targeted biopsy or a cognitive biopsy. Okay, so let's mark some areas, and I'm just literally marking these at arbitrary. Let's say it has a focal enhancements. Let's give it a PyRads 4. We press OK, and now that information is actually stamped onto the image. So let's look at how we would interpret a little bit further other than looking at a glaringly apparent area. So as we already saw, we have an area here within the ADC, and then we have the subsequent DWI. So the important part is to look whether or not these same areas are actually showing any type of reaction based on kinetics. So under the right click, this section here controls your left mouse click. So the correlate button here is the one that actually gives us that crosshair and correlation that show where we are within the anatomy. Subsequently, what that does within the color values themselves, it shows us what the kinetic curve is. So our coloring would be, the blue coloring would be our type 1 persistent curve, the green coloring would be our type 2, our plateau, and then the red would be our washout. So as we see, that same area that we see of interest is showing your classic uptake of a higher value and then our classic dissipation of a type 3 curve. So where we can actually look for, because you know how the PyRads lexicon now really looks at the positive and negative, we can actually turn the color overlay off, and that's where we do this option here. So if we look underneath the image, and what I'm using is the right and left arrow keys on my keyboard, I can actually go from phase to phase and see where the femoral arteries start to highlight. So from here is where I want to call something early enhancement, late stage enhancement, or just global overall prostate enhancement. And now we can start to see as the anatomy starts to fill. Now anything past probably time point 8 to time point 12 is not necessarily useless information, but is not going to give you as much as just turning the color overlay on and then looking at the physical curve. Anything within this area is where we call that early stage enhancement, and that's what the PyRads lexicon wants to look for. All right, so we created an ROI. Remember, that's associated already to the axial T2. So in the realm of a case that we would prepare for URNAV, we can actually just close and save, and we would essentially be done with the process. The URNAV will import what it needs. Now let's look at a situation that we know that we'll have better specificity, especially when it comes to the ADC. So let's say we want to look at the segmentation of this area. Now we know that this sequence is not listed in blue. So the important part here is that if I create my ROI on this sequence and I end and I close, the URNAV is going to be blind to it. So we don't want to do that. But I'm going to go to the same process again. I'm going to go to right click, then my freehand ROI. I'm going to left click and hold and drag my area of interest. The reason why this one pops up is just because I have multiple processing. So just press OK if that does come up. Remember that we do have our LinkedIn width. So if we remember, what do we do from this point? Good, right click inside the ROI, go to our first option, go to edit make 3D, and then we just chase our lesion around. Now this one's actually rather large, so I'm just gonna skip to the beginning, middle, and the end, just for the sake of time. Now I'm gonna right click outside the ROI, remember, and edit. So here's the volume of my lesion. Remember, we have our longest, our shortest, and orthogonal distances. We can right-click inside the ROI. We can edit the PyRads info if we like. But now from this point here, we have one ROI, but in this case, we would have two. So how would we get this sequence to transpose onto the axial T2 that the URINAV needs. You're going to right click inside the ROI once it's created, and you're going to come here to associate to, and then choose the axial T2 in parentheses. Now for you, regardless of the version of the software that you have, whether it is the 3.3 or the 4.0, this workflow is exactly the same. Now it is important to make sure that you are transferring it over to the same axial T2 as we spoke of, because again, then the URINAV will not be able to see the sequence, and then you'll have one ROI with another one missing. So from here, if we are again done with the case, we would close and save, and then we would go on and open our next study. So taking it one step further, let's actually look at creating a report. Now, once the ROIs are created, we come here to our image captures, or to our reports, excuse me. So we'll press OK. This only comes up because this patient actually has a comparison study. I'm going to press continue. And now what the system is going to do is going to calculate that information for me. So as long as I did the ROI, as long as I did the gland segmentation and I approved the boundary, again, I have my CC volume, my measurements, we can get the PSA value from the patient's EMR. And then from here, we can actually calculate a PSA density. This section here is actually not designed to replace your PowerScribe dictation. But if you do want to make individual notes, you can do so. We had some customers that like to take this and print it out and give it to the customer, or attach it to the patient's EMR and be able to place specific notes. It just kind of gives you a little bit more control, I guess, when it comes to how the urology staff is going to be receiving your report. We do have the option to add it to our PowerScribe. That is a purchasable option. So if you do like to look at that, that's definitely something you can talk to your account manager about. But as you see, we do have the gland segmentation itself, and we have the ROIs found within the gland segmentation. As you can see here, we did the PIRADS breakdown. If we go a little further, we actually have the size dimension, the compositional information, and then our KEP and TOPS modeling. We're going to talk about that a little bit later on when it comes to the advanced portion of it, because there's some really cool information that I did want to show on that one. And then, of course, the scoring that we spoke about. The really cool part here is that you would actually have somewhat of a cognitive fusion. So kind of like we spoke of before, when we don't have a facility that has a fusion device, they can at least see a 3-plane location and be able to somewhat find the lesion if they're relatively larger in size. And if we have our second ROI, as you can see, we have the same compositional information and the same reformatted breakdown to be able to archive this back. So from here, what we would do is hit Save as Diacom. At the end of the study, we would click Mark as Read. So regardless if we're taking image captures or we're creating a report, that workflow is still going to be the same. So you take your image captures, we would come then take your Save as Diacom, which gives you that Diacom tag. Then at the end of the study, we would hit Mark as Read. So let's look at the image captures. Your image capture tools will be here. So Capture All will capture everything exactly the way you see on screen. Capture Image will capture the individual image that's highlighted. So let's say we want to capture just the images. I'm going to capture all. As you see, a camera flashes all the way across the screen. I'm going to come over here to my view captures. And then under my view captures, here are my captured images. So for those of you that actually like to use tumor board and reporting for DynaCAD, I'm actually going to delete these quickly, and I'll cover the delete as well. Let's say we want to take an image capture, but without keeping the patient information off. This is where the graphics overlay comes into play. So we'll turn the graphics overlay off. As you see, it anonymizes the study. If I click it one more time, it takes all the annotations off. And if I click it again, it just brings it all back. So let's just say I want to take an image capture. Capture here, and let's say we want to take a capture there. We would then go to our view captures, and here are our anonymized images. What you would do is hit Save as Bitmap. It's the same form of just a JPEG, and then we just go straight into the standard Windows function and be able to save it to your local computer. So now to delete these series, you would hold down the delete key on your keyboard. As you see, it changes to the X. I left click, and I can just delete whatever sequences I don't like. So I'll go ahead and bring the graphics overlay back on. And now, essentially, we are done with most of the process that you would actually have to work for. So remember, 99% of your workflow is literally what we just covered. So how to, one, create your ROI. First, we would start with the gland segmentation, be able to go to the gland segmentation and make our adjustments. Remember, we would hold down the control key to do our hotkey with our glands, our region of interest. We would use the shift key to go to your smooth function. And just remember, after we've contoured all the areas, we want to hit the approve. Just don't forget again, remember that you can use the non-reference image, which is under the right click, which allows you to do those quick reformats just to help a little bit more with the segmentation. Once you're happy with everything, remember we hit approve, and we're essentially ready to go. We would come now back into our ROI. We would double click to go full screen. If we're still needing assistance finding the ADC values, remember under the right click, we can go to the Fusion overlay. We can place that information onto the overlay. And this is something that typically you won't have to toggle off and on, but if you left click and hold here, it just brings it off and on if need be, but you still have the same option when it comes to your color overlay here. So when it comes to the hangings, these are the type of hangings that we can actually put together for you. So looking at the hangings themselves, the hangings tab will be top left-hand side. So this is the default hanging. In my case, it's actually tied into my F4 key. So if I hit F4 on the keyboard, it will automatically reorder the hanging to what I have as my default. From here, under our prostate lesion analysis, this is something that we're going to dive into a little bit further. But I like to show here when it comes to your color overlay. So your color overlay, this is where I would actually place your fusion map. As you see, it's already set as a preset, our dynamic series with the color overlay, and some of our higher end maps here. So these are the type of hangings typically that we'll use for our prostate exams. But 99% of your workflow, you're pretty much going to work off of your main screen because it's going to be displaying all the pertinent sequences that you want. So I'm just going to quickly just delete just to clear up our area here. So let's say your hanging protocol doesn't look like this. If you right click under any series, the first option you're going to see is everything that you have acquired during the study. So this patient actually has a comparison already in the system. That's the reason why 2 of them are showing. But normally you're going to have probably just 1 that you're going to be able to choose from. You would put the sequence that you want to place down. And let's say I just want to place my dynamic series, and it places the sequence where I wanted it to. To override your hanging, you would come to your hangings tab, you would right click, you would hit save, you hit save again, and now this is my updated hanging. So from here, just remember that you're able to use your right and left arrow keys to be able to go from phase to phase. That allows you to look for those quick focal highlights. We can turn the color off and on when it comes to our options here. Under the right click menu, this section here controls your left mouse click. So if you choose any one of these options, it's going to remain that option until you physically go back to correlate in order to get your time intensity curve, and as well as your plane location. All right, so now let's deep dive a little bit further into some of the tools and some of the options that you have. So as I said before, we can actually create different hangings. And now let's look a little bit more into the lesion analysis. So this part doesn't necessarily go into our advanced users, but has a little bit more robust information. This is one step that you technically don't have to take your interpretation into, but we do know there's a lot of subjectivity when it comes into the prostate exams. So let's get into what's going to happen with those like make or break cases or where you're just not 100%. So let's use the same area that we spoke of interest. So I'm going to go ahead and create my ROI. This time I'm going to use the top toolbar. I'm going to left click and hold, and I'm going to drag my area of interest. Again, I'm going to right click inside the ROI. I'm going to go to edit, make 3D. Just going to scroll to my next slice. And this gets a little muddy, but we'll include it there. All right, right click outside the ROI, and then we're going to go to End Edit. All right, I'm going to double click just to get out a full screen. And now let's see exactly what we're looking at. So we know that when it comes to our kinetic understanding, the kinetics now, where it comes to the lexicon, really wants you to look at positive or negative. Is it enhancing or is it not enhancing? Now, one thing that where it comes to how to help the interpretation is specifically what we're looking at within the mapping itself. And now I'm not a radiologist, so I actually learned based on taking all this information and be able to say that this is a positive case without a shadow of a doubt. The way I'm able to do that is because once I create the ROI, the mapping that shows us here on the top right-hand side is actually showing how the blood flow is specifically happening within that three-dimensional area. So you've already created the ROI. What we can do is actually show how to interpret that. So if you don't have this specific wash-in map, if you right-click and come under your chart, so here would be your chart. If you're looking at a diacom image, you would come over here to your wash-in. If you have some kind of a chart already here, just right-click and it takes you straight to it. So this is where the wash-in map is coming from. So on the y-axis, you're looking at your wash-in characteristics. So kind of like the rate of velocity of flow. And if you're actually reading breast exams, this is the exact same process. So from here, you're looking at the initial uptake as a wash-in characteristics, and then our wash-out characteristics on our x-axis. So we can see that the rate of velocity of flow, where the majority is actually showing more of a medium enhancement. So this shows, as we see, our type 3 curve, and then we have mixed kinetics with our type 2 and type 1 and type 2. So you're not going to ever report specifically on percentages, but you are going to be able to see where the majority of your area is coming from. The reason why that becomes important is because if we're looking at a case whether we're going to call something a PI-RADS 3 or a PI-RADS 4, it's going to make the decision whether or not that patient is going to go to biopsy or not. So from there, if we call something a 3 and know the patient's going to go on active surveillance, we want to make sure that we're making the specific classification so we don't end up placing a patient on a 6-month hold. So that's what we can see with this specific area of interest that we spoke about, is showing a medium enhancement. On the map that we're showing here, which is the joint histogram map, and again, under right click, we're going to go to the joint histogram. We're looking at our K-trans values, and then we're looking at our VE values on the x-axis. So the K-trans is going to be your permeability rate. So the faster the rate of velocity of flow, the faster the area is going to have that leaky effect. And then the VE is your extracellular volume. So as you start to increase your cellular volume, you're starting to see that the cluster of the points that you're looking at are found all within this ROI, which fall within that same medium area. So if we would call this a PI-RADS 4, just because of its location and its size, we know if this patient goes to biopsy, more than likely we're falling somewhere within the Gleason 6 to the Gleason 7. We're right at that cutoff, is because the more it starts to leak and the more of that contrast is found within the extracellular space, the more likelihood we're looking at those 7, 8, and 9. So what that means is that if our ROI falls lower within the scale on the bottom right-hand side, we're pretty much rest assured that that patient is going to have an actual cancerous event. So it just gives you that extra confirmation that it's like, well, I'm not 100%. Well, let's just take a quick peek and see what the maps are actually telling us. So double down with that is actually going to be our K-trans. So now I'm going to come over here to our color maps. So part of our color maps now, we're looking at that same leakiness effect. So we would look at the highlights of space. So here on the upper right-hand corner, we're actually looking at our K-trans values. On the lower right-hand corner, we're looking at our KEP. So the K-trans values, as you see, we're seeing that same blush of color that we have from that same area that we found of interest. And then your KEP is going to be kind of like a dedicated washout. So if you have a patient, especially that has a prostatitis or some type of inflammatory response, a lot of times we'll see really blush kinetics. They're type 3 curves all over the place. This map here is actually going to help separate those areas that are showing higher rates of initial wash-in with a higher rate of wash-out. So it gives us a little bit better understanding as to what's happening within the anatomy instead of just kind of guessing, well, this all looks type 3 to me. Now, one of the things to consider is that you do have to have some kind of a T2 correlate. So if you don't have some kind of a demarcation on your T2, a lot of these values are just normal glandular enhancement because we're doing the prostate gland enhances quite a bit. So now, if you do have the 4.0 version, let's look at some of the really cool options that we have there. Now I'm going to come out and go into a different case. The reason why I'm going to go to this case, because this is a really good case that I like to show simply because of how the area actually is showing up on the ADC. Sorry, give me one quick moment, we're just loading. So what we're going to look at is, especially when it comes to those areas where we're not indefinitely looking at a T2 correlate, because sometimes where it comes into the contrast values, where it comes into the T2 weighting, or where it comes into just the overall patient anatomy, there are some other factors that may be coming into play. So looking at the T2, as doing a very quick dive, one thing that we look here in the peripheral zone, we can see there's asymmetry. We can see there's a little bit of an area, but probably not enough that would call to dictate that type of reaction. So now let's look at what the ADC is telling us within that same area. So instead of having to guess, now we can see plain as day that our ADC is now showing us quite a bit of an area of interest that's more than likely affecting the disease tissue. So with that being said, knowing that we're looking at the higher B values give us the highest specificity, let's look at what some of the options that the 4.0 version can do for us. So if you come to the Home tab, the same way that we can click onto the hangings gives us the option to actually give you your calculated B values. So instead of having to try to make the calculation at the magnet level, which some magnets just don't have the capability, you actually already had that tied into the software. So as long as you're acquiring multiple B values, as you see, we have a 0 and a 1000 value, and in this case, they just had a separated 0 and 1500. But we'll take this initial one. We can calculate this out to whichever value that you want, which usually the literature wants you about 1400 or 2000. We'll generate an ADC map if we want to, but what we can do from here is actually do a side-by-side comparison now. So once I've done that, I can right-click, go to that same first option that shows everything that I have acquired. We come all the way down to the bottom, and here's my calculated ADC value. All right, let me zoom this up. So now I can actually see my calculated ADC value, and I can put that side by side with an actual acquired value. Sorry, let me put the BWI. So now we can see that here is our acquired and here is our calculated. So as you can see, we have much more structural, spatial resolution where it comes into the anatomy, and we can see it is just as bright as we were actually coming with the acquired value. So this is a really cool option in order to be able to get any magnet to essentially calculate up to those higher values, as we know that the literature right now is actually telling us that the calculated values are just as good as the acquired values. So that's definitely an option to look into if you're not currently on the 4.0 version. So when it comes into the process that you're needing, like I said, 99% of your workflow is what we covered in the first 5 to 10 minutes. Remember your gland segmentation, how to turn your color overlay off and on, how to go from phase to phase. And then from there, under the right click, if you need to set your hanging protocol, place the sequences where you want them to, override them on the hanging protocol, and then of course create our ROIs after we've done our approval of the gland segmentation, close and save, and you're ready to go. So I hope this has given quite a bit of information. The last little bit, this is really more covering into the reporting features where it comes into some of the K-trans values for those that really like to get into the research aspect of it. So I'm going to quickly create just a 2D ROI just really fast. And that was extremely sloppy, but I'll let it go this time. All right, once we're done loading here, all right, so from here, we'll do just the reporting. So once you come to the lesion analysis, just know you do have data sheets that you're able to export into Excel spreadsheets. And that's really our time. So I really wanted to appreciate, I believe we want to open up for a little bit of question and answers, just in the event that you have some questions in regards to the process. But just remember, only take away what you need to, try to simplify it as much as possible, and all the tools will be right in front of you just to get you through your cases. Pete? All right, so let's take a quick look at the chat.
Ed, can you hear me okay?
Yes, I can.
Okay, great.
All right.
No, listen, thank you so much. That was really wonderful. We might have a couple quick questions here. I did want to point out to everyone that, as Ed mentioned, this is the 4.0 platform, which I think many of you are on. But if you're not, we can certainly connect with you to see what upgrade options there are available to you.
What do the tests mean? What do the tests mean? Are there good antibody tests? Are there bad antibody tests? My system.
All right, so I believe there was a quick question in regards to temporal resolution. I'll just jump on that one real quick, Pete.
Yeah, please.
The temporal resolution, you can only get down to about 12 seconds. That's actually still within range. So we allow anywhere between 5 to 15 seconds. The lower the temporal resolution you're able to get, the easier it's going to be to use the focal enhancements. So if you can't get it down to past 12 seconds, you're still within the range of tolerance that we allow. So you're still going to be good there. If you can get it down a little bit lower, probably within 10 seconds is a little ideal. So I just have them play around with the matrix a little bit and see if that helps out.
That's great. Sorry, Ed, I would think I might have been on mute again there a second. You can hear me now, okay?
Yeah.
Great. So yeah, thank you again for your time. Thanks everyone. There are certainly options for upgrades. If you want to reach out to us, we can help with that. And many of you are on service contracts currently, which is great. So, these sort of sessions we can do one-on-one, just, connect with your in vivo account manager. We also, plan to, we did record this session. So if there's any colleagues that you might want that we could pass this on to, or you all for another quick review, happy to do that. I will also mention we have a customer resource portal as well that we could get you connected to, and there's a number of videos and vignettes on there, certainly a little more short little snippets, if you will, but that's something that's certainly available. I think I'm looking at the chat session if there's any other, any other questions. There was a question about the calculated B-value again and what that is good for.
Certainly. So the calculated B-value, the reason why that's important is because some magnets don't have the capability of calculating out to higher B-values. So if you're acquiring a magnet that's showing, let's say, a B-value of a 0, 400, and 800, the higher the specificity, the greater likelihood you're going to show those Gleason 7, 8, and 9 that are still going to highlight. So what we're doing is actually calculating out the exponential curve as if you're acquiring it from the magnet level. And that's where this value is coming from. So in this same scenario, if we load our calculated B-value, this is a B-value of 1500, and we can see that the area is still showing as a highlight. So by it being at a 1500 and still showing signal, this will pretty much tell us that this is an active lesion, and more than likely this patient has cancer. So that's where those calculated values come from. So especially depending on your software version from your magnet, this is definitely an option that will help compensate instead of having to spend 12, 13 minutes acquiring a 1500 B value, and then unfortunately the resolution just not be there.
Great. Thanks, Ed. Okay, I don't see any other questions unless anyone wants to throw one into the chat real quick. Otherwise, we appreciate everyone's time. Again, we can review this one-on-one if need be, no problem. If there's any interest in other solutions from your colleagues, whether it's, breast MRI, lung cancer screening, neuro solutions, and certainly anything in the Philips oncology portfolio, the multidisciplinary tumor board in particular is an exciting one that we see. And really would enjoy one-on-one sessions with you all on that. So thanks again for your time. Ed, thank you so much. Really appreciate it. And we will see you all soon. Thank you.
Thank you for having me.
All right. Bye-bye now.